In this episode, we take the networking primitives you already understand and use them for a very specific defensive purpose: segmentation, which is the practice of dividing a network into purposeful zones so that compromise in one area does not automatically spread everywhere else. Segmentation is not about making networks complicated for the sake of complexity, and it is not a fancy feature reserved for experts with giant environments. It is a way of thinking that starts with a simple question: if one system is taken over, what should it be able to reach next, and what should it absolutely not be able to reach? When you answer that question honestly, you begin to design networks that contain damage instead of amplifying it. Beginners often imagine attacks as single events, but most real incidents involve movement, where an attacker pivots from one foothold to more valuable targets. Segmentation exists to make that pivot harder, slower, and easier to detect, which is exactly what reducing blast radius means in a cloud setting. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first thing to clarify is what blast radius actually refers to, because the term can sound dramatic while describing something very practical. Blast radius is the amount of your environment that can be affected when something goes wrong, whether that something is a compromised identity, a vulnerable workload, or a misconfiguration that exposes a service. In networks with weak segmentation, the blast radius tends to be large because many resources can talk to many other resources without meaningful barriers. In strongly segmented networks, the blast radius is smaller because reachability is deliberately limited by design. For beginners, it helps to picture a building where every room connects to every other room through open hallways, compared to a building where sensitive rooms require passing through controlled doors. If a fire starts in one room, the open hallway building allows smoke to spread quickly, while controlled doors can slow it down. Segmentation is the network equivalent of those doors and fire breaks, and it is built using subnets, routes, and access rules in intentional combinations. Lateral movement is the attacker behavior segmentation is designed to disrupt, and it is worth understanding in plain terms. Once an attacker has access to one system, they typically try to discover what else exists and what they can reach. They may scan internal address ranges, attempt to connect to management interfaces, look for databases, or find shared services that can provide broader access. If the network is flat, meaning many internal paths exist by default, that discovery is easy and fast. If the network is segmented, discovery is constrained because many destinations are simply unreachable, and the attacker receives fewer opportunities to try. Beginners sometimes assume that internal networks are safe because they are private, but private networks can still be wide open internally, and that openness is exactly what lateral movement exploits. Segmentation adds structure to the internal world so that internal does not automatically mean everything can touch everything. A common beginner misconception is believing that segmentation is achieved by creating multiple subnets and calling it a day. Subnets are important building blocks, but segmentation is about reachability decisions, not just address grouping. Two subnets inside the same VPC or VNET can often route to each other by default, which means the path exists unless you deliberately restrict it. True segmentation combines subnet design with route planning and with rules that control what traffic is allowed. It also requires deciding which systems belong together and which should be separated. For example, public-facing entry points should not sit in the same zone as databases, and administrative management pathways should not be casually reachable from application workloads. When you put the right things together and keep the wrong things apart, you reduce the chance that compromise spreads. In other words, segmentation is a design decision first and a configuration task second. To design segmentation intentionally, it helps to think in terms of zones, where each zone has a clear purpose and a clear set of allowed interactions. A zone might represent public entry points, application services, data storage, shared internal services, or administrative tooling. The key is that the zones have different risk profiles, and that difference should be reflected in connectivity. Public-facing components accept inbound traffic from the internet, so they should have very limited outbound reach to internal systems, and they should be treated as higher risk by default. Application services often need to talk to databases, but they should not need to talk to management interfaces or to unrelated services in other parts of the environment. Data zones should accept connections only from specific application components, not from every random internal system. When zones have clear interaction rules, you can reason about what is normal and what is abnormal, which makes investigations much faster. Beginners benefit from this zoning approach because it transforms a messy network into a set of understandable relationships. Route design plays a foundational role in segmentation because routes determine whether a path exists at all. If there is no route between zones, then traffic cannot flow, which provides strong isolation without relying on perfect rule configuration. This is where the earlier idea of treating routing as the skeleton becomes practical. You can associate different route tables with different subnets so that some subnets have paths to shared services while others do not. You can control whether certain subnets have outbound internet access directly through a NAT gateway or not at all. You can also limit cross-network connectivity by controlling which networks are peered or connected through transit. Beginners sometimes focus only on firewalls and security groups, but route boundaries can be even stronger because they remove reachability entirely. When you combine route-based isolation with rule-based filtering, segmentation becomes more durable. Access controls still matter, though, because many zones must communicate in limited, specific ways. Security groups, network access rules, and service policies act like door locks on top of the building's walls. They allow you to say that the application zone can talk to the database zone only on a specific port and only from specific sources and not in broad, permissive ways. Beginners sometimes create rules that are too wide because they want things to work quickly, and then they forget to tighten them later. Intentional segmentation requires the opposite habit, where you start with narrow allowances and expand only when there is a clear need. This can feel slower at first, but it reduces risk dramatically because every permitted path has a reason to exist. It also reduces troubleshooting time later because fewer open paths means fewer confusing interactions. A network that is too open behaves like a room full of people all talking at once, where it is hard to hear anything meaningful. Segmentation decisions should also consider how identities and management access work, because lateral movement is not only about network connections, it is also about the use of credentials. If an attacker compromises a workload and finds credentials inside it, they might use those credentials to access other resources through permitted paths. Segmentation can reduce the usefulness of stolen credentials by limiting where those credentials can be used from and what those identities can reach. For example, management interfaces and administrative control paths should be in a zone that application workloads cannot reach directly. If administrative access is required, it should flow through controlled jump points or managed access services, and it should be heavily logged. Beginners should connect this to the earlier idea of least management surfaces, because segmentation can reduce the number of management pathways that exist at all. When management networks are isolated, compromise of an application server does not automatically become compromise of the entire environment's control plane. Another often overlooked segmentation goal is protecting shared services, because shared services can become accidental highways for lateral movement. Services like directory systems, logging collectors, or internal package repositories may be used by many workloads, which makes them attractive targets. If an attacker can compromise a shared service, they may gain access to many dependent systems. Intentional segmentation treats shared services as high-value targets and limits which zones can reach them and how. It also avoids placing shared services on broad networks where everything can connect by default. Beginners sometimes assume shared means safe because it is internal and centrally managed, but shared often means high impact. Protecting shared services through segmentation reduces the chance that one compromise turns into many. Segmentation also supports better monitoring and detection because it creates clearer expectations about traffic. In a flat network, almost any internal connection might look normal because everything can connect to everything. In a segmented network, connections between zones are fewer and more purposeful, which makes unusual connections stand out. If a workload in the public-facing zone tries to connect to a sensitive data store that it should not reach, that attempt becomes a strong signal. Even if the connection is blocked, the attempt can be logged and investigated as a sign of compromise. Beginners should see segmentation as improving visibility as well as containment. It reduces the noise of random connectivity and highlights activity that violates the intended design. When your network has clear boundaries, your logs tell clearer stories. Cloud environments add a special challenge because segmentation must account for scale and speed. Resources can be created quickly, and new services can appear in different regions or accounts, which means segmentation cannot rely on manual, one-off decisions. Intentional segmentation is often implemented through standard patterns that are reused, so new resources inherit the correct zone placement and connectivity controls. This connects back to the idea of landing zones, because landing zones can define baseline network segmentation and ensure that new projects start within the intended boundaries. Beginners sometimes think segmentation is a project you finish, but it is more accurate to treat it as a standard you apply repeatedly. When new systems follow the same zoning model, the environment remains predictable. Predictability is a security advantage because it reduces surprises, and surprise is what attackers exploit. It is also worth addressing the fear that segmentation will break applications or make troubleshooting harder, because that fear causes many environments to remain flat. Segmentation can cause connectivity issues if designed without understanding dependencies, but that is not a reason to avoid it. Instead, it is a reason to design deliberately and test assumptions about what needs to talk to what. When you map dependencies, you often discover that many connections are not needed and were only convenient defaults. Beginners can think of segmentation like organizing a workspace. Putting everything in one pile feels easy until you need to find something quickly, and then the pile becomes a problem. A segmented network, like an organized workspace, may take effort to set up, but it reduces confusion over time. It also makes incident response faster because responders can isolate zones without shutting down the whole environment. As you think about reducing blast radius, it helps to tie segmentation to business impact rather than treating it as purely technical. Some systems are more critical than others, and some data is more sensitive than others, and segmentation should reflect those realities. High-impact assets should be placed in zones with stronger isolation and tighter access rules. Lower-risk systems can exist in more open zones, but even then, they should not be able to reach everything. Beginners sometimes struggle to decide where boundaries should be, but a simple guide is to separate by trust level and by function. Systems exposed to untrusted inputs, like internet traffic, belong in more restricted zones, while systems that store secrets and sensitive data belong behind more layers. When you align segmentation with impact, you create a design that makes sense to both security and operations. It becomes easier to explain and defend, which is important during audits and incident reviews. Intentional segmentation is ultimately about designing your cloud network so that compromise is contained, movement is limited, and unexpected paths are rare. You reduce blast radius by creating zones with clear purposes, controlling reachability through routing, and enforcing narrow connectivity through access rules. You limit lateral movement by isolating management pathways, protecting shared services, and ensuring that internal does not automatically mean unrestricted. Along the way, you also improve detection because clear boundaries create clearer signals in logs and monitoring. For new learners, the most important shift is realizing that segmentation is not an optional add-on, and it is not something you do only after a breach. It is a foundational safety design that helps your environment fail smaller instead of failing big. When segmentation is built in thoughtfully, it becomes one of the most reliable ways to keep cloud incidents from becoming cloud disasters.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.